Here is the next example. In this example, similar to the previous examples, we're finding transfer function from the signal flow graph. Okay, so step 1, find all the forward paths. So I can see, forward path is nothing but starting from input, reaching the output. So I have P1 equal to Z1, Z2, and Z3. That's a one forward path. Another forward path I see here is going through Z4. Okay, so I see path 2 is only Z4, nothing else. Okay, that's my step 1. Any other forward paths you guys see? I don't see any, but I highly recommend you to thoroughly go through it. Find out if you miss one forward path, that will lead big error in your final answer. You will lose lots of points there. Okay, now step 2, find all the loops. Okay, so loop 1, I can see a loop right there, which is minus h1. Okay, and loop 2, I can see minus h2 as another loop. Loop 3, I can see, can I say minus z3 h4? That's one loop. That's my loop 3. And loop 4, can I take this as loop 4? Let me use different color. Here's, I'm going to use blue. So can I take this as loop 4? Okay, loop 4, z2, z3, minus h3, z2, z3 minus h3. Okay, those are the 4 loops I see. Do you guys see any other loops there? Okay, inspect a couple of times before you move to the next step. Okay, now step 3, non-touching loops. Okay, so first find 2 non-touching loops. So 2 non-touching loops. So 2 loops which are not touching to each other, 2 non-touching loops. Okay, 2 non-touching loops. I see L1 and L2. They are not touching to each other, either at the node or at the path. Okay, I would say L1 and L2, they are not touching at all. Okay, and another one, I see L1 and L3. L1 and L3, they're also not touching at all, not touching to each other at all. Okay, so those 2 are the non-touching loops. Okay. Now find delta. Step 4. Step 4, find delta. Delta equal to 1 minus all loops, L1 plus L2 plus L3 plus L4. Okay, plus sum of the multiplication of 2 non-touching loops. So which is nothing but L1 L2 plus L1 L3. So that's multiplication and sum of the individual sum of the loops. Okay, if you have 3 non-touching loops, so you need to check, are there any 3 non-touching loops here? I forgot to explain. So 3 non-touching loops. Are there any loops which are not touching to each other? Okay, say for example, if you have L1 and L2 and L3, they are not touching to each other, then you can put L1, L2, L3. Here I don't have any, so I'm going to put none. Okay, so if I have any 3 non-touching loops, so I'm going to put minus of product of those 3 non-touching loops. Okay, so here those are none, so I'm going to eliminate that part. So this is good enough. So delta equal to, in this case, delta equal to 1 plus, I have what do I have? Okay, here it is. So minus of everything has minus get cancelled out. So 1 plus h1 plus H2 plus Z3H4 plus Z2 Z3 H3 plus L1 times L2, which is minus H1 minus H2, which is going to be positive H1 H2 plus L1 L3, so minus minus get cancel. I'll end up with Z3 H1 and H4. That is step 4. Now step 5, find delta 1 delta 2, because we know that the transfer function equal to transfer function t equal to p1 delta 1 plus p2 delta 2. So I have only 2 forward paths, so that's the reason I have only 2 elements there. If I have more, p3 delta 3, like that, over delta. So I know this, I know this, I know this. I don't know delta 1 and delta 2. So how do you find delta 1 and delta 2? So to find delta 1, take the whole delta and see, are there any elements or nodes which are touching path 1. So here we are finding delta 1. Delta 1 is, keep the delta there, except are there any elements which are touching the path 1. So I'm going to put 1. H1, is it in path 1? So if you look at path 1, this red line is the path 1. Okay. If you look at H1, that is touching, at least that element is not there in path 1, but at the same time it is touching at the node, so eliminate that H1. Okay, H2, same thing with H2, eliminate that. Z3H4, so Z3 is there, so eliminate that. Z1, Z2, or Z2, Z3, eliminate that, because Z2, Z3 are in there. H1 and H2, yes, eliminate that, because those two are in that path. Okay, eliminate that. Z3, so Z3, H1, H4, Z3 is in there, so eliminate that. Delta 1 equal to 1. Okay, now delta 2, and I'm going to use the blue here. Delta 2 equal to, now I'm going to put 1. Okay, I'm finding delta 2, so put 1. Now H1, so path 2 is right here. Oh, I believe I didn't draw everything. Let me draw. So here is path 2. Okay, this is my path 2. Okay, so I'll put 1. H1, is it touching our path 1? No, I mean our path 2. I'm talking about path 2. So it is, H1 is away from this path 2. Okay, and it is not touching it at a node or the path. So for sure include that one. Same thing with H2, include that one. Okay, now Z3H4, okay, look at this. Z3H4, is this node included in our path 2? Yes, that node is included in our path 2. So Z3H4 is touching at that node, so do not include that. Okay, and Z2, Z3H3, they're touching at that node, do not include that. H1, H2, they are not touching in that path, so for sure I'm going to include that. Plus Z3H1, Z3H1, H4, Z3H1, H4, they're touching at that node, so do not include that. That's our delta 2. Okay, now transfer function, the transfer function equal to, transfer function t equal to p1 delta 1. So I have p1 equal to z1, z2, z3 times 1, delta 1 is 1, plus z2, p2, path 2 is, I have z4 times delta 2, which is 1 plus h1 plus h2 plus h1 h2 divided by delta. I'm going to write everything, 1 plus h1 plus h2 plus z3 h4 plus z2 z3 h3 plus h1 h2 plus C3, H1, H4. Okay, I hope you understand better with this example, but I'm going to solve at least another 1 or 2 examples. Thank you.